Okay, so in Unit 5, Part 5, in the new packet, page 1, we're going to go over whether pairs of data are in a proportional relationship. And we can use tables, graphs, or equations to determine if these relationships are directly proportional. So first, we're going to look at equations. And a linear equation that goes through the origin represents a proportional relationship. So if a linear equation goes through the origin, that means that b equals 0. So whenever you look at a linear equation and you put it into slope-intercept form, or y equals mx plus b, if b equals 0, then you know it represents a proportional relationship. And the slope, in addition to being the slope, is called the constant of proportionality. Okay? So let's first look at a graphic representation. So here, I'm going to draw two linear equations. One of them represents a proportional relationship. One of them does not. So you think to yourself, is it line A or line B? Hopefully you said the answer is line B, because it's a line that goes through the origin. This is a line, but it doesn't go through the origin. So this is not a proportional relationship. And the next one is a proportional relationship because it goes through the origin. Okay, now let's look at the equation. So we can look at an equation and decide if this is a proportional relationship or not. And the way we do it is we put it into slope-intercept form and we see if b is 0. So here, I'm going to subtract 4x from both sides, and then I'm going to divide by 2. So I have it in the form of y equals negative 2x plus nothing, or plus 0. So b equals 0, which means, yes, this represents a proportional relationship, because if I was to graph it, it would be a straight line through the origin. Okay? And since b equals 0, if I was going to ask you what's the constant of proportionality, you would tell me the constant of proportionality, which is sometimes a, sometimes k, and in this case m, the constant of proportionality is negative 2. Okay. So now let's look at the next one. So I want to know if this equation represents a proportional relationship between x and y. I'm going to determine that by putting it into slope-intercept form. When I put it into slope-intercept form, I see that b equals 3. Since b equals 3 and not 0, that means it does not go through the origin. Therefore, it is not a proportional relationship. And there is no constant of proportionality. So if I said, what's the constant of proportionality, you would just say there is none, because the slope is not it in this case, because b does not equal 0. Okay, I have to move this. Give me a second. There. Okay, let's go on to the next page. And the next page says, sometimes these equations are called direct variation equations because y varies directly with x. So like I said before, sometimes you'll see it in a textbook and it'll tell you y equals kx, where k is the constant of proportionality. But it could also be y equals mx, where m's the constant of proportionality. Now, if y equals kx, and I asked you to solve this for k, how would you solve this equation for k? Well, I'd want to isolate the k, so I would divide this side by x, because now k is alone. So I'm going to divide this side by x. So to find the constant of proportionality, all I have to do is put y over x. Okay? So when you know it's a proportional relationship, you know the constant of proportionality is y over x. So if they give you a bunch of data, giving you ordered pairs X and Y, and you want to know if it represents a proportional relationship, all you have to do is put Y over X. And if every time you put Y over X, it's proportional, it's the same value, then you can say, yes, it's a proportional relationship. So in this case, 2 over 1 equals 2, 4 over 2 equals 2, 6 over 3 equals 2, and 8 over 4 equals 2. So since every time I put Y over X, it equals 2, 2 is the constant of proportionality. And this does represent a proportional relationship. Now, if that is the constant of proportionality, I know my equation would be Y equals 2x. Sorry, wrote that weird. So Y equals 2x. That would be the rule. Y equals 2x. Now, let's think about if we graph this, what is it going to look like? Well, I know if it is a proportional relationship, it's going to be a straight line that goes through the origin. So since B, or my y-intercept, is 0, I start there. I go up 2 over 1, up 2 over 1, up 2 over 1. And look, it's a straight line that goes through the origin. And if it is a straight line that goes through the origin, and I want to know what the constant of proportionality is, I know that the constant of proportionality is the same as the slope. So if B equals 0, the constant of proportionality is same as the slope. Okay? So now they give us a different, let me move this. They're giving us a different chart, and they're asking us, can I find the rule to this chart? Now, since it's very likely this could be a proportional relationship, the first thing I want to do is figure out if it's a proportional relationship. To do that, I'm going to put Y over X. Well, in this case, Y over X is negative 1/2. But then I look here right away and I see that this is negative 3 and that this is undefined. So I'm like right away, okay, this might be linear, but it's not a proportional relationship because there is no constant of proportionality. So let me just see if I can still find the rule. And I think back to how we found the rule. So I'm adding 2 here. I look for the change in Y, plus 2, over the change in X, which is plus 1. So I know my multiplier is 2. So this is Y equals 2X. But now I have to say, well, let me plug in this. And if Y equals 2 times negative 2, which is negative 4, what do I have to add to turn it into a 1? And the answer is 5. So let me see if it works for this ordered pair. Y equals negative 2. Sorry, it's negative 1 times 2, which is negative 2, plus 5. And that does equal 3. And the other one is Y equals 0 plus 5, and 5 equals 5. So my rule does work. So in this case, let me make that clearer. I know that it's Y equals 2X plus 5. And I could have taken a shortcut and said, well, look here. When X is 0, whatever this number is going to be my y-intercept, and B is my y-intercept, so it makes sense. Okay, so although this was a linear relationship, and it did form a straight line, it did not go through the origin, so it's not a proportional relationship. Now, and then I was supposed to graph that. So this was Y equals 2X plus 5. 1, 2, 3, 4, 5, up 2 over 1, down 2 over 1, down 2 over 1. And not surprisingly, it's a straight line, but it does not go through the origin. So that makes sense that it's not proportional. Okay, so here is another chart. I want you to stop the video and try to find the rule, decide if this is a proportional relationship or not, and graph it. And start the video up when you're done. Okay, so now, first thing I'm going to do is try to find the rule. And here, to go from -2.5 to -2, I add 1/2. And to go from -2 to -1.5, I add 1/2. And this is changing by 1. So I know my multiplier is 1/2. And if I do 1/2 times 1, it's 1/2. And how do I turn that into -2.5? I subtract 3. So let's see if my rule works. What is 1/2 of 2? It's 1. And 1 minus 2. So I did something wrong. So let's go back. Okay. So y equals 1/2 times 1, which is 1/2. And 1/2 minus 3 is -2.5. So let me try this one again. Y equals 1/2 times 2, which is 1, minus 3 is -2. So I am right. Don't know what I was thinking. And then I say y equals 1/2 times 3, which is 1 and 1/2, minus 3 is -1 and 1/2. So this is, in fact, my rule. It's not going to be a proportional relationship because it does not go through the origin. So up 1 over 2, up 1 over 2, up 1 over 2, and it looks like this. So again, since it doesn't go through the origin, it's not a proportional relationship. Also, what I could do is say, well, if it was proportional, y over x should equal a constant. But if I do -2.5 over 1, that's -2.5. If I do -2 over 2, which is y over x, that equals -1. And if I did -1.5 over 3, that equals -1/2. So this is definitely not a proportional relationship because when you put y over x, it's not constant. Okay, so I think we're going to stop the video there, and we'll have a new one for page 4.